The square root of x minus 2 equals 5 is an example of a radical equation. What makes it a radical equation is because there's a square root in it. It could also have a cube root, a fourth root, or any other power root. Our goal in solving a radical equation is the same thing as it would be in any other equation, to get the variable alone. When we have any equation, we have to ask ourselves, how do we undo an operation? For example, if we just had x minus 2 equals 5, we would ask ourselves, what's the opposite of subtraction, which would be adding 2. But in this problem, it's under a square root, which means I need to ask myself, how can I undo a square root? Well, squaring is the opposite, or will undo square rooting. So I will square both sides, and that means on the left-hand side, I'll be left with x minus 2. And on the right side, I need to square 5, so I get 5 squared, which is 25. Now I have an equation that I can solve by adding 2 to both sides, and x equals 27. If I go back to my original problem, the square root of x minus 2 equals 5, if I plug in 27 there, the square root of 27 minus 2, that is the square root of 25, which is 5. So my answer checks out, and x equals 27 works. If I had the square root of 2x plus 1 equals negative 3. If I go to square both sides on this, I'll get 2x plus 1 equals 9, and then I get 2x equals 8, and then I get x equals 4. But when I plug this back in, 2 times 4 is 8, plus 1 is 9. The square root of 9 is not negative 3. There is no solution to this problem. In actuality, we would have known that in the very beginning. Just like absolute values, square roots cannot equal negatives. So when I see that square root there, I know that there will be no solution for my answer, and I don't have to do all of the work. Now here are 2 more examples of radical equations. These both happen to be cube roots. So to undo a cube root, I will actually cube both sides. So on the left side, those will cancel out, leaving me with x minus 3. I need to figure out 5 cubed, which I can type into my calculator, and I'll get 125. Then I'll add 3 to both sides, and I get x equals 128. If I were to check that, I would get 128 minus 3, which is 125. And the cube root of this is 5, and I can check that in the calculator using math for 125. On the right-hand side, if I look at this too quickly, I might think there's no solution because of the example on the previous slide where the right-hand side equaled a negative and it didn't work. But this is a cube root, which makes things different. So I'll cube both sides, and on the left side, those will cancel out, leaving me with x plus 1. On the right-hand side, when I cube negative 2, I will get negative 8. I'll subtract 1 from both sides, and I get x equals negative 9. When I plug that in, negative 9 plus 1 is negative 8, and the cube root of negative 8 is negative 2. Because this power here, the index is odd, that's why my answer works. Cube roots of negatives do work because I'm doing negative 2 times negative 2 times negative 2, which will give me an answer of negative 8. Here are 2 problems. Please hit pause and try them by yourself. Now, if you're ready to see the answer, go ahead and hit play again. We will square both sides here. We get x plus 7 equals 4. I'm going to subtract 7, so I get x equals negative 3. Negative 3 plus 7 is 4. The square root of 4 is 2, so this one checks out. On the right-hand problem, I will cube both sides, and I'll get 3x equals 64. Divide both sides by 3, and I'll leave this a fraction of 64 thirds. Okay, please try both problems before you hit play again. So hit pause. Now the problem on the left, hopefully you notice the fact that it's equal to a negative, and square roots can't equal negative, so our answer is no solution. The problem on the right, maybe you thought of a square absolute value problem and you realize that you shouldn't have something out in front to start. So the first thing we're actually going to do is to get the square root alone, just like we would get the absolute value alone. So I'll divide both sides by 3, leaving me with the square root of x plus 1 equals 4. Then I can go ahead and square both sides, and I get x plus 1 equals 16, which is x equals 15 for my final answer. The same thing would happen if I had the square root of x minus 2 plus 5, which is not underneath the radical, equals 12. Before I can square both sides, I do need to move that 5 over by subtracting it. So I have the square root of x minus 2 equals 7. Then I will square both sides and get x minus 2 equals 49. So x equals 51. So remember to isolate or get the square root alone before you square both sides. Now in this particular problem, we can't isolate the square root because there's a square root on both sides. But if we just square both sides, we'll see that the square roots will cancel out, leaving us with x minus 3 equals 5x plus 1, and then I will go ahead and solve for x on both sides. So I'll get negative 4 equals 4x, divide by 4, and I will get x equals negative 1. Now, when I go back to check and I plug this in on both sides, I'll get the square root of negative 1 minus 3 equals negative 5 plus 1. I do get the square root of negative 4 equals the square root of negative 4, which technically we've not talked about square roots of negatives yet, but this does in fact work. Try this problem before you hit play again. Hit pause now. Now here's a better example than the previous one. When I square both sides, I'm left with 3x minus 2 equals x plus 2. I'm going to get my x's on the same side, so 2x minus 2 equals 2, add 2 to both sides, so 2x equals 4, so x equals 2. When I plug that back in, I get the square root of 6 minus 2 equals the square root of 2 plus 2. So I get the square root of 4 equals the square root of 4, which is good. So this solution makes sense and works. Now, when we go to square both sides on this problem, we do have this 2 here, which is a problem. If we try to divide both sides by 2, we do get rid of it on this side, but we end up with this nasty fraction over here. So in this case, we don't want to divide by the 2. So if we go back to the original problem, and we square both sides, we just need to square the left-hand side very carefully. The right-hand side will be left with 5x minus 8. On the right-hand side, we need to square both the 2 and the square root part. So 2 squared is 4, and the square root of x minus 2 cancels out to be x minus 1. Then I'll distribute the 4, and I'll get 4x minus 4 equals 5x minus 8. I'm going to skip a little bit of work on this one so that it shows. We get negative 4 equals x minus 8, so x equals 4. If we go ahead and check this, our solution will work. We'll get 2 times the square root of 3, and on the right-hand side, we get 20 minus 8, which is the square root of 12, which does break down to 2 root 3. So since both sides equal 2 root 3, my answer of x equals 4 works. Here are 4 problems. Take a minute to try number 1 before you hit play again. Okay, now, go ahead, check your work with number 1, see if you've made any mistakes, see if you can figure out what they are. Try number 2, hit pause now. Don't hit play until you're ready to check number 2. I chose to solve this problem by squaring both sides, because if I were to divide both sides by 4, 3/4 doesn't reduce. I could have done that, and then when I squared both sides, just squared the 3 and gotten 9, and squared the 4 and gotten 16. I chose to square both sides and make sure that I remembered that 4 squared would be 16. Either way will get you the same answer, and either way is correct. Please try number 3, so hit pause now. Look over your work for number 3. Make sure that you don't forget the negative in front of the x, because that belongs with the x, not with the 2. You're subtracting 2 from both sides. That's where the 23 comes from. Once again, hit pause and try number 4. Once again, check your work, see if you understand it. If you do, go ahead and check your homework. If not, be prepared with questions for tomorrow, or try watching one of the pieces of the video again.